This video lecture provides a background on climate as it relates to the concepts in ecology and the environmental sciences. The primary source for this lecture is Smith & Smith, Elements of Ecology. The systematic pattern of water movement or currents is determined by the global pattern of prevailing winds. The circular water motions or gears occur in each ocean. The ocean current moves clockwise in the northern hemisphere, and the ocean current moves counterclockwise in the southern hemisphere. Latent heat is described as a measure of the amount of energy released or absorbed per gram during a change of state. In going from a more ordered state, such as a liquid, to a less ordered state, such as a gas, energy is absorbed. Evaporation is the transformation of water from a liquid to a gaseous state. In contrast, condensation is the transformation of water vapor to a liquid state. When the evaporation rate equals the condensation rate, the air is saturated. Water vapor is an independent gas that has weight and exerts pressure in the air. Vapor pressure is the amount of pressure water vapor exerts. The water vapor content of air at saturation is the saturation vapor pressure, and if this is exceeded, then water condenses. Relative humidity is the amount of water vapor in the air expressed as a percentage of the saturation vapor pressure. At the saturation vapor pressure, the relative humidity is 100%. If air cools while the water vapor pressure remains constant, then relative humidity increases as the saturation vapor pressure declines. The temperature at which saturation pressure is achieved is the dew point temperature. Precipitation is not evenly distributed across Earth. A general rainfall pattern exists on Earth where precipitation is highest in equatorial regions and declines as you move north and south. The declines of precipitation are not continuous because of prevailing wind effects. The Intertropical Convergence Zone, ITCZ, is the region that forms where the trade winds meet and is characterized by high amounts of precipitation. Rainfall is generally greater in the southern hemisphere because the oceans cover a greater portion of the southern hemisphere. Water evaporates more readily from the surface of water than from terrestrial areas. The ITCZ migrates towards regions of the globe with the warmest surface temperature. The migration of the ITCZ is responsible for weather conditions as seasons change in the northern and southern latitudes. Mountainous topography influences local and regional precipitation patterns. A rain shadow forms on the leeward side of a mountain or mountain ranges due to the loss of moisture from the air as it travels up and over the mountains from the windward side. The climate system of Earth is characterized by variability at both the regional and global scales. The variations in Earth's climate system operate on timescales ranging from decades to thousands of years. Sunspot activity affects the climate on Earth. The ocean and atmosphere are connected to some major climatic variations that occur at the regional scale. The El Niño Southern Oscillation, ENSO, is one example. During the Southern Oscillation, the surface pressure is between the southeastern tropical Pacific and the Australian-Indonesian regions. During an El Niño event, the waters of the eastern Pacific are abnormally warm and sea level pressure drops in the eastern Pacific and rises in the west. During an El Niño event, the trade winds slacken and reduce the westward flow of the surface currents. There is a reduced upwelling and warming of the surface waters in the eastern Pacific. In contrast, during a La Niña event, the surface of the eastern Pacific cools more than usual. Organisms may live in local conditions that do not match the general climate profile of the larger regions surrounding them. Microclimates define the specific conditions, for example, light and heat, organisms live in. As an example, compare the conditions experienced by an insect at the ground surface to one at the top of a tree on a windy day. As well, topography influences the local climatic conditions. Aspect, or the direction that a slope faces, is of particular importance to microclimate conditions. In the northern hemisphere, because of differences in the exposure to solar radiation, south-facing slopes experience warm, dry, and variable conditions, whereas north-facing slopes experience cool, moist, and more uniform conditions. The opposite is true of south and north-facing slopes in the southern hemisphere. Urban areas create their own microclimates, which are significantly different than those in rural areas. Urban areas are generally several degrees hotter than the surrounding countryside and are referred to as urban heat islands. Urban areas are generally warmer than the surrounding countryside because there is less vegetation. There are more buildings, streets, and sidewalks that absorb solar radiation and re-radiate this energy. The urban landscape is non-porous, and most rainfall is lost as runoff before evaporation can cool the air, and construction materials are great conductors of heat. The heat island effect can raise temperatures in urban areas 6 to 8 degrees C above those in the surrounding countryside, and it has a negative impact on air quality within urban areas. The following sources were consulted in developing this video lecture, including content, quotations, and images.